All right, thanks everyone for coming along today. So today Ryan's going to give a talk about his research into the Objectiviverse.
Cool.
Thank you.
Cool. Thanks, Adrian. Today I'd just like to talk a little bit about the research I've done at the HitLab, and the main objective is really to give you a bit of insight into the community that the system is being kind of built and made for. And so I'll be showing you lots of videos from the community, which I think kind of captures some of the ideals that are represented by it. And I also have a whole bunch of books and materials to show you, just because I thought it's nice to be exposed to those things and to have a bit, physical things to look at and view while you're here. So, okay, I've got a bit of a plan, and what that plan first involves is me running a video. So I'm going to do that first. This is just some demo stuff of what I've been working on, and that way that will just sort of play in the background, hopefully, if YouTube does what it should do. Let's try that again. Cool. All right. Well, hopefully that will work. So what I've made is a poi tracker, basically, but it's a little bit more, I guess, general than just poi. Any object which can have basically tracking lights, the system can track, and it tracks them pretty fast through space at about 125 frames a second, because I'm using a PlayStation 3 camera, which is ideal for that kind of work. The resolution of it is pretty low. It's only about 320 by 240. But because I'm working with really large objects, that's not too much of a problem. Another big advantage of using this PlayStation 3 camera is that it has a 75-degree field of view. And that's really nice if you're working with a large space. So if you take like my arm length plus this poi length and extend it out in both directions, you're reaching about 3.5 meters. So that's why you want a camera with a large field of view. In the research, I explored a few different cameras. One of them is the Kinect. What I found with the Kinect is that while it has the advantage of being a depth camera, it doesn't track fast enough. So the rough speed that these move at is about 1.5 meters per second. So at that speed, you actually need something that can track pretty quickly if you want to get lots of data points. And as you can see on the display behind you, each one of those little circles represents a data point, so it's pretty well mapped out. And that's at about a distance of, I think it's about 2.5 meters away. Yeah. Another camera I looked at was the Wiimote. Now, that appeared to be an ideal kind of camera because it could run at 100 hertz, and it was great for tracking infrared light. But its field of view is only about 30 degrees, and you just can't really track things in a sufficient way for that. Through the work I did with tracking, I found using an RGB color model is not a good idea. There's just too much variance over time, and that's a real shame. So I looked into using a hue, saturation, and brightness color model, which I found yielded far more consistent results. And I'm using OpenCV to do the tracking. And that's part of Open Frameworks. Now, the reason I chose to use Open Frameworks as opposed to say, building something entirely from scratch was to save me time, first and foremost. The other reason I chose to use Open Frameworks was it provided me a series of functions like a distance calculator and a very simple set of functions to draw onto the screen. I didn't have to go about writing lots of code to do this for me, and that was really convenient. I did notice, however, there's a few issues with using Open Frameworks. It has two main functions. One of them is a draw function, and the other one is an update function. Now, Open Frameworks guarantees that the update function will be called before the draw function on every frame. However, it's bound to it, which means that if you set 60 frames per second in your draw function, then your update function will also be called at only 60 frames a second. And because I'm dealing with something that is 125 frames a second, then I don't actually get a very fast frame rate. It also means that I can't run VSync because, of course, normal LCD monitors run at 60 Hertz. So I have to disable VSync in order for this to work. A solution around this would be to use threads so that I could run this and run the actual update code for the object tracking positions in the background. Here on the screen is just an example of some of the hue, saturation, and brightness channels separated. And so what I've got is these objects being tracked, but I also have geometry on the screen. And that geometry can be used in a few different ways. One of those ways is kind of for exploration. Performing artists and object manipulators will visualize geometric shapes and frameworks in their mind's eye when they're creating patterns and shapes that are aesthetically pleasing. So I wanted to kind of take those images outside of the mind's eye and place them in the world. So I found this had the advantage of really, I guess, consolidating or making sort of manifest the images that a performing artist is seeing. And that's both for the viewer and for the artist. So the exploration can help the artist look at any particular part of the geometric structure and then think about, well, new places that they could go within that structure. So in a way, it allows for creative exploration. There's also a more sort of, I guess, stricter training system that I have in place. And that's been the main sort of part of my research. And basically, I have these paths that have been laid out using this simple system of points and connecting lines. And I can create a pathway such as this here. The pathway, the objective is to move along the pathway. And I also have boundary markers, which aren't shown on this screen, but those boundary markers act as a kind of way of keeping you within that area. I have some visual feedback, which tries to sort of indicate where you've been, as well as whether you are you've hit all the markers in successive order or not, or whether you've missed one. Yeah, so that's like some of the rough idea that's been motivating me. Some of the background for this is that, well, artists will use areas around their visual, around their body, that they will use as, I think we call them focus points. And the focus points are these spaces where you're looking if your object passes through at that point in time. So I found that pretty interesting and pretty helpful. Yeah, okay, so I'll move on a little bit now, and I'd just like to mention, so I also wanted to do a study and see whether this system for feedback, the type of feedback I'm providing, i.e. the trails and the indication whether you've missed any checkpoints or whether you're doing well or not, provided a better, I guess, a better form of feedback than another more traditional form of training that artists use. The more traditional form of training involves, say, standing in front of a mirror and watching yourself as you perform some patterns. The reason you stand in front of a mirror and do it is because the patterns that you're doing are actually outside of your field of view. So unless you're looking at it, unless you're looking at it, then you can't actually see what's going on. So you actually have to feel what's going on. But being able to look in a mirror allows you to see a much wider area that encompasses you. And if you want to do it with respect to some geometry, then you need to draw on that mirror. You just draw a shape or a pattern, kind of like what you're seeing on the screen. And you can do that with some tape or with just using an erasable marker or something like that. So I kind of mimicked those ideas in the system that I've made. But I guess mine's a little bit more powerful in the sense that I can press a button to change the pattern that's on the screen, whereas if you've drawn it on a screen, drawn it on a mirror, you have to erase it and then start again. So it takes a lot more time. So I did a study where I compared these two notions. And I had 21 participants through. And what I did was I wanted to compare between feedback and no feedback. So I used my system to measure that for both conditions, but I turned off the feedback for one of them. So that is to say, you would not see the trails anymore, and you would no longer be giving any indication about whether you actually hit these markers or not. Yeah, so I found through some analysis, and what I was analysing was how many successive points they hit in a row before they made a mistake. And what I found was that there is some statistical significance that says that feedback is more helpful than no feedback, which is yay, all very good and true. Yeah. So I guess what I'd like to do is sort of turn away a little bit from the stuff that I've made and turn more to, I guess, more of some of the philosophical background about like what is object manipulation and like why is this sort of stuff important. Yeah. So I find this stuff very, very important. I started learning this when I was doing my undergraduate, and it was an outlet for me to, if I needed a break from my studies or something like that, I could just do something that kind of felt like I wasn't having to just exist in my head, just think about things in my head, and it was nice because in a way it kind of grounded my thought to my body. And it wasn't about mindless movement, it was about intentional movement. So I really had to think about what I was doing at every point in time. And that was great fun. Now I learned a few tricks from a few friends, and I thought that was really nice. And then I ended up going to a festival where I was shown by some professional artists the kinds of frameworks that they work in and the type of geometry I'm showing you today. And I found that absolutely inspiring, that they could conceptualize this in their head in real time and then create these patterns for people to look at. Moreover, there's a lot of mathematics behind it. I mean, what we're kind of doing here is actually using parametric equations to create shapes for people. And you can work in many different planes, different planes being like, well, this would be called a wall plane, and then you can have another plane here, which would be called the wheel planes, and you can be behind you, which would be called the back plane. You can use the floor plane, and all that kind of stuff. And what I found with this community is that it's actually filled with people who are constantly using different forms of technology to help improve or, I guess, inspire or just create really interesting things that people have never seen before. So that's been really nice to look at. And so I guess what I'd like to do is talk a little bit about affordances of objects. So this is coming sort of Donald Norman's The Design of Everyday Things, where he talks about an object having a set of affordances, that when you look at an object, you think, okay, it's capable of these things. What we should always bear in mind that when we're talking about affordances is that it's actually a relational property. We look at an object and based on what we currently know about that object, we make a set of assumptions about what it can do. Performing artists, I would say, look at objects in a very different kind of way, in a more theatrical way, let's say. This theatrical way is not looking at what this object is, i.e. this thing is a cup or this thing is a sphere. It's looking at what you can make this object out to be, what you can do with it. And in a sense, what an object is what you can do with it. So you see people exploring possibilities that were otherwise hidden from view or hidden from their perception. And so I find that quite interesting in that the more we explore objects, the more we interact with them, the more affordances they have. I mean, a few years ago, poi was not really used for throws, but some of the technology that's come out is that now we have counterweights on them. And so these counterweights can be thrown, and you can start doing lots of tossing movements with that, and you can start incorporating, say, the movements from juggling into your poi movements. The technology of the community is also really quite impressive. Not only we do lots of stuff with fire, and it appears very dangerous, but actually it's not really dangerous. It just looks it, and so which is a lovely thing to sort of be able to convey to people. Yeah. So this video. Oh yes, sorry. I'd like to jump back just quickly and show you some of the visualization I've got with my system. Now this is what I thought about is that when I ran my numbers to do my statistics in my study, I found, okay, great, statistical significance, but this doesn't really help the individual in their sort of training regime into getting better with patterns. And so I've just quickly made this type of visualization, and this is their path over the recorded time that I did. And so this particular pattern you'll see overlaid underneath, and then you'll see each one of these sort of white circles as representing where they've actually moved over time. And as you can see, the objective here was to create this pendulum pattern, which has people go into a circle here and then pull up and pull across. Yeah, and you can see that for this particular person, they usually would go a little bit higher on these two sides. And I think that's really interesting and really telling if someone is wanting to learn, saying like, oh, okay, I need to focus on these areas to improve my improve the sort of consistency of my patterns. And I have that for the different patterns that I showed participants. So, for example, here's another one, and you can see down, I guess, what would I say, down at this bottom right area would basically be where they started and stopped a lot. Okay, let's start again. There we go. Yeah. And I have another one here for another pattern, and you can see that around here they probably had made lots of mistakes, so just down this little area. So I found that quite interesting. And we can again see in this region over here, it's a pity you can't really see it, I can see it on my screen, but in this region around here, there's also a lot of extra, circles which would represent that they're actually going, making little mistakes and not being able to be as consistent around their sides. And then here's another one. This pattern has people moving in this way, so it's a stall pattern, stalling back and forth. And as you can see, that would happen a lot. Yeah, so that's one of the challenges with stalls, is to actually reverse the pattern and not have it move beyond its path. And then here's another participant with that same patterns I showed you before, and you see that they're having slightly different representation here, where they'll actually be a little bit further on this side and about the same on this side. Yeah, so I just wanted to show you that. Cool. So yeah, natural born cyborgs. So this is, I've talked a little bit about how objects can be used to, I guess, explore affordances and what we can do with them. But there's also the area about, well, what's going on in our minds when we actually do this. And it's kind of like driving a car in a way. When you're driving a car, I don't think you'd be really thinking about your body so much. You'd be thinking about the space that the car exists in and takes up as you move around. And when you're performing with objects and playing with objects, you see very much the same thing. Your focus is in the object. It's not in your whole body, it's in an isolated part of it. And that's where your sort of focus lies. This book, Natural Born Cyborgs, shows many really, really fascinating examples about sort of this phenomenon of the idea of our situatedness, our focus, and where our mind can direct itself. And I guess forms of like relaxation will have us often placing our awareness in different parts of our body and trying to actually like relax them with that intention and with that focus. So you see that sort of cropping up here too. There's also a paper by Daniel C. Dennett called Where Am I? And in this paper, he spends some time talking about where is the I, that is, like, where is your seat of consciousness? And what he gets us to do is entertain a scenario where he's been asked by some scientists to help, like, defuse a bomb. And they have made this robot that has conveniently visual perception and tactile perception and I think auditory perception. And they have this brain interface where he can kind of put it on his head, and then he will experience everything that the robot experiences. And what he would suggest is that when we put this on, we're no longer in our body. Instead, we're going to be where all our perceptual experiences. And I think it's probably right. It's probably what actually will happen, is that when we have an overwhelming amount of information coming to us, like we do all the time, our brain will reduce it down to just what is important for the directed task at hand, and will in a sense act as a filter. Yeah, cool. So I guess when you're learning objects, it's really important to think of what it's like to be a child again. The philosopher and psychologist William James, and I think it was 1890, said the experience that a baby must have is one great blooming, buzzing confusion. And I think that's quite a nice sort of way of thinking about what it must be like to be a baby. You're bombarded with sensory information all the time. But it's not quite right. The philosopher Immanuel Kant, he would say that we have to have sort of an initial set of conditions that kind of bootstrap us into the world. And for Kant, those were space and time. So they act as kind of organizing conceptions with which we can place things and make sense of them. And so for a baby, we would like to say that they have a sense of space and time, although that might not be that refined yet. And there's been some really interesting experiments that show babies react just like they would looking at their mother to a drawing of, say, 2 points and like a smiley face and maybe something that would represent a nose, and they react in the same way. So one could suggest that their neural pathways haven't developed to an extent to really differentiate or distinguish between a real mother and just something that resembles a mother. But as we spend more time in the world, we learn to discriminate these things to a much greater degree. And that's why we're so good at seeing what is on a face and things like that. Yeah. Cool. All right, so that's where I kind of wanted to say about that. The other thing was that when we look at technology, I think we're, in the kind of field we're in, we're all too quick to assume technology means computers or something electrical. I think really technology is any kind of interface that we have with the world, and our body is including that. So a baby has to learn to interface with the world through its body. And when we use objects for some sort of artistic intention, again, we're having to learn to use them to the same degree. Yeah. Cool. All right. So here's an example of a guy called Stalick. And he's an artist who did some bodily extension, where he kind of grafted a robotic arm to his arm, and he learned to control it just as well as, well, thereabouts, as well as we can control our arms. And what he did was he took some electrodes and placed them on his abdomen. And through the flexing of his abdomen, he could articulate this arm. And he said initially he had to think really hard about flexing his abdomen in kind of intentional ways. But after a bit of practice, he didn't have to think about flexing his abdomen anymore. He rather could think about moving his arm in intentional ways like we move our arms today. Yeah, I have another few images of him, which I think I'll leave on. So I'd like to move a little bit over to talking about or showing some videos from the community actually to give you a sense of what the object manipulation community is about, and yeah, to hopefully show you why we have this sort of playful disposition towards objects and how fruitful that is in the, I guess, discovery and in how we share information. So yeah, I've got this video to show you, so I'm just going to play that back here, and So, a couple of things I'd like to say about that. there are lots of people just trying. There's lots and lots of things all the time, and everyone in this community recognizes that you're going to make mistakes and you're going to make lots of them, and in a way that's a wonderful collective recognition to have that I think we maybe have forgotten a bit, at least in the schooling systems, where people, if they make mistakes, are actually punished for them. Whereas in this community, it is recognized that if you make a mistake, you're actually trying, and the more you try, the better you'll get at things. And so I think that's really lovely. And so yeah, it's people are constantly telling others that, oh, great job, great, really good to see that you're trying all this and you're getting better at it. And what you try to do is, when you're teaching something, is you want to direct their attention towards something that they don't quite see yet, just to help them out and to try to convey a concept. So another one I'd like to show you of a little bit of stuff in the American scene, and this one's quite good fun. So yeah.
Ignite Festival 这边搞完再讲那块搞。嘿，好。这个搞了好多坏开。这个搞的这叫 level up。Ignite Festival。
So yeah, that's just like a little taste of some of the fire arts, and how there's just, in a way, the community is constantly pushing itself to try new things and to explore them. So I'd like to move a little bit away from just festival stuff to show you some of the learning techniques and teaching techniques that are struggling to see on YouTube. Petal anti-spin flower in box mode. And this is a way of, once you understand the language, to extract these parts. moving on to that to this one. This is a good little example of how you can use geometry to help teach. This is a guy called Zan Moore, who is...
The first component part of what we'll work on tonight is the 6-pedal anti-spin. It looks like this.
So,
I visualize a hexagon in space and line up each outside point with one point on the hexagon. 1, 2, 3, 4, 5, 6. This is the wall plane, and this is the wheel plane.
So generally when you're learning a move...
The next component part we'll be working with is the 3-pedaled in-spin flower, or regular spin. It looks like this.
You want to make...
The points for this one count off the center. 1, 2, 3.
So his use of...
Right now I have one point at the top, but I could shift the orientation and put a point at the bottom.
Does it in real time instead of in post-production like you see in this video. But you can probably notice that...
Or even put a point at the side.
This geometry in real... He's just
doing
so much
2,
that
3.
He doesn't need it
1,
anymore.
2,
well,
3.
He doesn't need it.
The last major technique we'll be using tonight is the 3-pedal anti-spin. It looks like this.
Improvement.
I don't have time tonight to teach the whole move, but you can find it online in other places. It's called the 3-pedal anti-spin or the triquetra. It's also sometimes seen as the Mercedes. But this is a piece of moves we'll be using tonight. Notice that I'm pointing down. 1, 2, 3. 1, 2, 3. I could shift the orientation and start with an upward point. 1, 2, 3. 1, 2, 3. We'll start with is the in-spin or regular spin flower. One more third of a circle, so you don't get too locked into the habit of standing still.
Cool. So I just want to give you a taste of that one. Yep, nice. And so I also took my setup to this festival, and I'd like to show you just a real quick video on this. So this festival is just held on the top of Takaka Hill at a place called Canaan Downs, and it's just the most beautiful location. You're up so high on this hill that you're above the clouds, which is great. So it's got its own little microclimate, and it's a fantastic place to be exposed to world music and people from all over the world. So it's very multicultural. I'll just show you a little bit of that.
For us all to really enjoy ourselves, and you know, music is just the most amazing medium for that.
The motivation behind Luminate came from tuning into the heartache of the destruction that's happening to our environment and this beautiful planet, and just wanting to do something that may help nudge things in a different direction. So we felt that organising a music, arts and cultural festival with a focus on knowledge sharing and environmental sustainability would be a good medium to inspire positive change.
The most amazing place. It's just extraordinary.
The festival is the way to really add some momentum to the change that we desperately need right now.
I really like the sense of community that we have here as well. You know, everyone's been helping each other out.
It's a great role model and an example for people to take back into their lives and put back into their communities.
It's real great appreciation of world music and the world fusion stuff, the fusion of electronic music and live music. And this festival has really represented that, both with live bands and electronic artists and fusion artists. What I really like about Luminate is how grounded and how relaxed the vibe is here. You almost say it's a chill-out festival, except for there's lots of dancing.
Another interesting feature of Luminate is that they don't have any rubbish bins on site, nor do they have any recycling bins. You actually have to take responsibility for all of your rubbish yourself, and that creates a really nice atmosphere because the entire festival is completely clean the entire time, and it runs for 8 days, which is great. And they use their own toilet system as well, so they have like composting systems set up which will take the waste and then will, I guess, do some chemistry on it, which will then help to get it ready to put back into the environment and recycle. Yeah, cool. And so the final one I'll just quickly show you is just a couple of minutes of this video. This is a festival that I also went to do some teaching and things like that, and it's just outside of Wellington. So here's an example of a large workshop being taught. These are small festivals of 100 or so people. That's a steer wheel.
Hi, my name's Claire French. I'm the director of Under the Spinfluence. My performance name and the name that I go by generally is Frenchie, and my company is FrenchieProductions.com.
My name's Emma Neefus. I'm assistant director for the festival. When on site, I've been in charge of all the accommodation allocation and all the ticketing, and also making sure the kitchen have everything.
Over the summer, me and my friend Benji were talking about how awesome it would be to have a festival in the springtime when everyone's getting re-inspired. And Benji had a wicked name for a festival, which was Under the Spinfluence. So the idea was born there. It's a circus gathering, so it's kind of a cross between a gathering.
Them out, and people can come up with. So creative exploration is sort of working.
It's good to train anybody to go directions from the beginning.
There's workshops, so it's completely open to beginners, all the way through. We do more advanced workshops as well for people who've been doing it for a while. It's open to all ages, all levels.
All ages, that's right. All right.
The sort of workshops that we teach are poi, juggling, hula hoop, the sear wheels, which were they look like giant metal hula hoops that you kind of roll around on, acro balance. Loads of different circus skills.
So, I guess I'll leave it about there. So this just gives you a bit of a taste of different festivals and sort of how it's always very, they're kind of small, very community oriented, and sharing is just, of utmost importance, and people just exploring and trying things, and mistake making is very important in that. So I'll just leave you with one thing, and so these are called basically they're a meta-amide material that firefighters will use. It's called Nomex, when they're like fighting and things, when they're fighting fires, and so it's used to be flame resistant, things like that. And we use these in performing arts, and it's wonderful. It means you can do things with fire that you otherwise couldn't do. So I'll show you what I mean by that. So like I can do this, and this is like I can feel warmth, but it's not actually burning me. It won't actually burn me, which is wonderful to see. Like that we just use this technology and materials that have just never really existed before the last 20 or 30 years, and now we're actually using them all to do neat things. Yeah, cool. I think that will be everything. Thanks. Any questions? Yes.
So you've got a system in place which is the potential we use as a teaching system.
Mm-hmm.
And in that sense, your current system is using sort of absolute coordinates for the points that you need to pass through.
Yes, correct. Yes.
But in many cases, you may just be after an abstract shape, which is like the three-thing flower. You're just trying to get like 3 loops in those approximate places.
Yep.
Have you considered trying to, as you said, like you've got some kind of parametric models that you could use.
Mm-hmm.
If you tried to track the parametric model and whether the user is actually fulfilling that, as opposed to just getting through absolutely positioned points.
Yeah.
Have you thought about that?
Yeah, I have, and I mean, there's the complexity of doing parametric equations like that. So I haven't been able to, just because of my own limited knowledge on the topic. One way I've thought about doing it is instead of having an absolute geometry that is fixed in place, is rather to have it move with the person. So as they move, the geometry moves with them. And so, yeah. That's right, yeah. Yeah.
I think you've got a great system here. I really like playing with it.
Cool.
Even when I make mistakes. I was wondering, so what are your plans for, do you plan on integrating this, since you said it's such a small community that focuses on learning, do you plan to see how your system is adopted?
Mm-hmm. Yeah, I've had, by taking it to Luminate, I got to get an idea of like how it would be accepted by the community, and I was just the most amazing response. And people were they were loving it, and it was wonderful to see performing artists coming up and playing with it and seeing what they could do with it. Like there wasn't so much like this is how you use it. They were just playing and seeing what they could come and seeing what they could figure out from it, which was great. And other people at the festival would just wander up to it and either have a go, or they would just sit and watch other people playing with it, and that was a wonderful thing for me to see. And yeah, I had the most amazing feedback from it, so that was really helpful. And I got to do a bit of programming on the fly there to incorporate some of that feedback, i.e. different types of colours for the trailing effects, and just things to help, I guess, convey useful information as well as look really cool. So some of the idea is that you can use this as a live visualization system. So you could imagine some performers on stage, and so maybe in the middle of the stage you have a DJ doing some stuff, and then behind them you have a projector with some visualizations being projected. Well, you could have it set up so that the camera is in front of each performer and then is tracking the movement of their objects, and then incorporating those objects' movements into the visualization in a live kind of reactive way.
I'd also like to see.
Yeah.
Be interested in the data you collected.
Definitely. Yeah.
Study, but yeah, I would like to see, opposed to people that have never done this before, as opposed to performers,
Yeah.
the differences in before and after.
Yeah, definitely. So initially, from what I can tell, actually they, I've recorded each person for 2.5 minutes. It was for 3 minutes, but I only measured 2.5 of it. And I found that amount of time is probably not enough to really see a dramatic improvement. I think what actually happened is that within the first, say, 10 seconds or so, they very quickly got up to the level that they were going to be roughly around. And so looking at the data that I have, I don't think I can say that they improved over time, but I can say that for the 2.5 minutes, they did markedly better with feedback versus non-feedback. Yeah. Yeah.
Right, I'll start by saying something that might sound a bit sacrilegious, but
cool.
It's a paraphrase of something that a guy from IBM told me once at a conference, which is a system like this, which you build for performing artists, and which is really beautiful and fantastic for the purpose.
Yeah.
Might be difficult to get funded in a way that makes it sustainable.
Yeah.
And I was actually challenging this IBM guy about some disaster response, systems that they had proposed for cities, which sounded really great, but which I didn't see anybody investing in. And what he said they do is they build these systems for the wonderful good of mankind purpose.
Yep.
And then they find ways to repurpose them. Things like logistics management and so on.
Yeah.
So they repurpose the functions into something that someone will pay for. And then the functionality is there when other people want to use it.
Awesome.
And so I think you might easily think of other ways in which this could be useful for things that people will pay for, so that you can develop the tool which is also available for performing artists.
Yeah.
That's
you can use it for dance, right? Like you can put balls on the end of people's hands and fit and use it for teaching dance, right?
Yeah.
Beyond that rehabilitation and stuff like that.
That's right. Yeah. I was thinking that, if someone has sustained an injury, that I could, with, say, you could have someone who could create a series of movements that would help to rehabilitate someone who has sustained an injury, and that way, not only would they, would the physio be able to get real-time information about is the person actually performing these movements, but they could also check, how well they're doing with respect to what they actually should be doing. So
that's fantastic. Also, some theorists who look at body skills that are practiced to the point of automaticity, tend to think of expert tool use in terms of the extension of the body schema beyond the limits of the body, rather than increased expertise in the use of the body to manipulate a tool.
Definitely.
So instead of me learning how to swing an object really well, what happens is that the part of my mind that maintains the awareness of where each part of my body is extends itself into this tool that's swinging. And that's a slightly different model. You might want to be aware of it when you're thinking about how to think about what it means cognitively. For this to assist learning. So, I'm not saying one is right or not, but I'm just saying other views exist.
Yeah, that's awesome. I'd just like to respond to that quickly. So there's another book by Andy Clark. I showed you the Natural Born Cyborgs one, but this is called Supersizing the Mind, and it's subtitled with Embodiment, Action, and Cognitive Extension. And the rough idea is that we can extend our cognitive capacities through the use of external tools. And that's very much like extending our body's image. Such as, driving a car is a good example of that. We have to be able to extend our body image to even drive a car, otherwise we would keep hitting things.
One of the things which is, can you, for example, from a kind of a shape that you draw in 3D space, reconstruct the required body movement to do this?
Yeah.
And I'm asking why, because it's a lot like continuing what he was saying. There is a company in Israel which is quite making a very good money, because they sell shoes. With these shoes has they design the kind of half a circles with different sizes in the shoes, which is force you like some muscles in the body based on this design to work in some places, kind of like to have pressure more on it. And they have having kind of very good progress, like good result with the people who's using these for various kind of like not only injury kind of muscles. If you can come up with something which is along these lines, that you will create a pattern, that this pattern, the people will play to create this pattern as part of a game.
Yep.
At the same time, they may be kind of also dealing with the hand, because as I told one of them, and they say they find, because you know they design the shoes and the people just walk with these shoes, they walk in upward like way, but it's just for 2-3 days and they see good result, but they don't know how to do with hands.
Yeah.
This seems to be actually a very good idea, but the issue is how you can translate kind of this kind of a nice shape into a game where people will play with it.
Yeah.
Did you think about something that kind of back in gym?
Yeah, that's fantastic. Yeah, no, I really like that idea a lot. And what I'd like to work towards is sometimes instead of using geometry as the standard to work just to make your movements fit to, is that you could just record the pathway that someone has moved through, and then over time that pathway could become slightly thicker to show like a well sort of trodden road or something like that, and then another person can come along and try to mimic that, very much in the sort of the vein of a kind of a Guitar Hero style game or something. I guess like
Boy Hero.
Yeah, Poi Poi Revolution.
It's kind of like you don't know how much this is consistent. You use people to say draw this shape. Someone who's like you, someone who's experienced with this, and you realize they need to do kind of like to do this shape. They get this kind of like kind of movement. Then you maybe try to get a model which is you will get these 3D shape and translate this to the body movement. Then you say here's the shape which is I want you to play with.
Yeah, and this is going to exercise these muscles and work in this way.
Like
Well, one of the things I mentioned earlier about moving the geometry with the body, well, the way that I thought about solving that problem is using a Microsoft Kinect, because generally the body is going to be moving slower than these fast-moving objects. And when you have the skeletal map of a body, you can see where the actual joints and the limbs are, and that way you can direct it in far more, expressive ways and get them to move in far more articulate ways. And I didn't mention this, but I also have sound generation working, and that's just basic sine waves, but it gives an auditory indicator about whether they're hitting the checkpoints in succession or whether they've made a mistake. So sound is another sense that I think could be very well used. Personally, when I've been playing with it, I would close my eyes and just listen to get to to do the movements that I wanted to do. Yeah.
Or maybe I like so much your system because it's really fascinating and hypnotic. You can spend hours watching it and watching it. And maybe you were not thinking in the applications. I guess it's just art per se. It's beautiful because maybe it's not a direct application, but people use the system. And maybe the place for this system is a museum or an interactive museum or something where the people can feel that they can create art.
Yeah.
And they can have fun and they can have some kind of stimuli for their sense. I guess it's the most beautiful part of your system that, in order to describe it, it's fascinating.
Well, thank you.
Yeah.
Well, the main idea for me was to get something that was fast enough to actually be immediately useful. So if it wasn't running it in a real-time capacity, then that lag, I think, would have really hindered the playfulness of it. Someone would try it a bit and be like, oh, this is taking too long to get the response that I'd like to see. And being able to test in a really rapid way of back and forth, I think allows people to really have a lot more fun with the system. So yeah, definitely.
I enjoyed it, you said.
Oh, thanks.
I might just stop it there since we've gone over time, but let's give another big hand for Ryan.
Thanks.
Don't forget you set up a permanent demo of the lab or something.
Yeah, definitely.
Bring people through.
Yeah, that's really easy to do too.
By the way, for everybody leaves, I have a story about Stellar.
Oh, cool. Yeah.
We visited the HitLab in the U.S. did a performance where he was stripped down, bare skin, and a loincloth, and he had hooks through his skin that were suspended from the ceiling with servo motors. And then people around the country would actually program his movement online. They would watch what he was doing, and he was hanging from the ceiling. And as he would move around based upon what people around the country were telling him to do, they wanted to move this way.
Yeah.
So that's art.
Yeah. Commitment, eh?
Anyhow, we spent about an hour chatting in my office, and this guy is far out, let me tell you.
Yeah, definitely.
And now he wants to use his body in performance.
Yeah, I mean, it's really interesting because when you start to think of cognitive extension and how we can create these fast feedback loop systems now, you've got to wonder, I mean, how much of it is going to be cognitive offload, but then what is that going to, give us the ability to do in the future? Extra sensory perceptions and things like that. If we want to, I know that there's some people are doing, they're doing sort of subdermal implants in their fingers of neodymium magnets, and when the nerves heal over these magnets, over time they can start to feel magnetic fields, and they actually build up the sense where they'll be like, oh yeah, there's a magnetic field here, and here's the shape of it, and things like that. It's just wild, eh? Yeah. So thanks very much to the HitLab for everything. That was awesome.